Once again, good morning and welcome to our Mathematics 9 class. As what I mentioned earlier, we're now starting with our third quarter. And I should say that the lessons in the third quarter are easy and manageable. So I believe you could still end up with getting a good grade. Now, lesson 5.1, or the whole chapter of lesson 5, is about quadrilaterals. And in our first lesson, we'll have an introduction to quadrilaterals. I know that you know what a quadrilateral is. You've been with this elementary and in grade 7, and we'll learn more on that in this lesson. Now, let's start by reciting today's memory verse. It's found in 1 Chronicles 9, verse 24. It says, "The gatekeepers were on the 4 sides, east, west, north, and south." And here is your MVCA boosters. You know what? I should tell you, if there's one thing that you should thank for getting a good grade in the past 2 quarters, it's your MVCA boosters. It gives you an extra of 5 points for a very good answer. Now, our MVCA boosters today is about the perimeter of the New Jerusalem. You need to read Revelation 21, verses 15-16. And after reading, you need to answer this question. What polygon does the floor of the New Jerusalem resembles? You could draw the polygon below and label the measurement of its length and width. It could be digital or it could be a photo of that. Then what is the perimeter of the base of the New Jerusalem? At the end of today's class, you'll be able to name different quadrilaterals and identify quadrilaterals that are parallelograms. Now let's start with a quadrilateral hunt. You can annotate. Now, you could use your annotate on top. Let's try. Let's encircle. Can you encircle quadrilaterals? Ready? I'll give you a minute to do that. You use your annotate on top, and you can start encircling all the quadrilaterals. Ready? Now, this was a quadrilateral, correct? The second is also good. Next, this one, yes. This one, and this one. Very good. So you see, I think you have a bird's eye view on what a quadrilateral is. Let me clear all of this. Let's go to the next slide. Now, what is a quadrilateral? The quadrilateral is a polygon with 4 sides joined by 4 vertices, and it has 4 interior angles. Now, here's a cue for you. Quad means 4. Like, for example, if 4 people are singing, you call it quartet, because that comes from the Latin word quad. It means 4. Latera means sides. So if you say quadrilateral, that's quad plus latera, it means 4 sides. In polygons, we can also call it tetragon. Tetra means 4, and gon means angle. So tetragon is the same as quadrilateral. 4 angles and 4 sides. Now remember, in a quadrilateral, there are 4 sides, there are 4 vertices, and there are 4 interior angles. In the drawing, the straight line is what you call the side. The angle formed by 2 sides inside is called the interior angle. And the point joining the 2 sides, we call it the vertex. The plural is called vertices. Now, here are some examples. You just count the sides. 1, 2, 3, 4, quadrilateral. Another, 4 sides, quadrilateral. 4, quadrilateral. Now, the other ones are examples, non-examples, sorry for that. Now, the other one are non-examples of quadrilateral. If you check, the first only has 3 sides. So we call it a triangle. The next is 1, 2, 3, 4, 5. My son would call this the house because he didn't know it's a pentagon. And the same with the other one, it's a pentagon. So again, a quadrilateral has 4 sides, 4 angles, and 4 vertices. Now, what are some parts of a polygon? If you say side, it's the straight line segment. If you say consecutive sides, consecutive means sunod. So for example, if this is a side, if you say consecutive sides, 2 sides with a common vertex. It means they are next to each other. The vertex is the point where the pair of the sides will meet. If you say consecutive vertices, sunod gapon siya nga vertices. These are the endpoints of a side. And a diagonal is a segment that joins 2 non-consecutive vertices. Example, remember we name a point using capital letters. Here, dili sunod. So A and B are consecutive vertices, but A and C are not consecutive vertices. Therefore, once you will join A and C, you form the diagonal. Let us have this one. Example, for figure A, B, C, D, we name the side with a line segment mark on top. Example, A, B, you need to place a line segment or a bar on top to say that it is a line segment or a side. If it's vertices, you could just name it with the letters because a point is named using a capital letter. So what are the sides? We have A, B, B, C, C, D, and A, D. Ma'am, can I also name this BA? Yes, you can also name it BA. But remember, AB and BA are just the same. Next, what are our vertices? A, B, C, and D. The next one, diagonals, non-consecutive vertices. A and C are non-consecutive. You join them, you form diagonal AC with a line segment on top. Next, B and D, you join them. Yes, that means it becomes a diagonal. Now, based on our figure A, B, C, D, we will name opposite sides. Opposite means atbang, right? So AB is opposite with DC. AD is opposite with BC. Next, opposite vertices. They are not consecutive. So A and C, then D and B. Another, opposite angles. If it's an angle, you need to place the angle sign. So we have angle A and angle C. The other is angle D and angle B. Now, let's have some special, some basic names for the quadrilaterals. Let's have the first one. It's called a parallelogram. Based on the name, parallel. It means both pairs of opposite sides are parallel. What are parallel lines? These are two lines on the same plane that no matter how long they will go, they will never meet. So you imagine if you have the tiles on the floor, these are two lines on the floor and they will never meet. Or if you have some lines on your ceiling, these are two ends of the plywood that will never meet. So it can be, ma'am, it can be long, yes. It can be small, as long as both pairs are parallels. Next, in a trapezoid, only one pair is parallel, the other is non-parallel. Example, these two are parallel. They will never meet. We call them the bases. These other two are non-parallel lines. Why? Because if you will extend it, then it will meet at some point. So these two are non-parallel. The next is trapezium. A trapezium does not have any parallel sides. So these two are not parallel. These two are also not parallel. The other one is called kite. A kite has two distinct pairs of adjacent congruent sides whose opposite sides are not congruent. Example, adjacent, right? So next to each other means consecutive. In a kite, these two are, Baba, these two are congruent, while these other two are also congruent, or say they have the same measure. Now, what are special parallelograms? What are parallelograms again? Two opposite sides are parallel. The first is a rectangle. A rectangle is a parallelogram. What makes it more unique? There are four right angles. So 1, 2, 3, 4. That is a rectangle. A rhombus is also a parallelogram. What makes it unique? It has four congruent sides. It means all sides are equal. The last is a square. A square is a parallelogram. What makes it unique? It has four right angles. It means it's a rectangle. And it is also having four congruent sides. So it's also a rhombus. That's why we say that the square is a rectangle. At the same time, the square is also a rhombus. Sorry, I think you could hear my son. He's playing in front. Now, we have some properties of parallelograms. The first property, in a parallelogram, opposite sides are congruent. So let me draw four parallelograms. It might look like this one, parallelogram. A rectangle is a parallelogram. A rhombus is a parallelogram. And a square is also a parallelogram. Now, in a parallelogram, opposite sides are congruent. So these two are congruent. These other two are congruent. You see, I'm making a mark. If it has one mark, it means the pair with one marks have equal signs, equal measurements. If it has two marks, another pair will also have the same measurement. So this one, these two are congruent, opposite sides. These two are congruent. Next, these two are congruent. These two are also congruent, right? These two are congruent, the other two are also congruent. Next, opposite angles are congruent. So this angle and this angle are congruent. You see, I'm making a 1 mark. I'll change my pen color first. While this one and this one are also congruent. 2 mark. It means that pair is congruent. The same here. This and this are congruent. The other two are also congruent. Here, opposite angles are congruent. The same with this one. What do you mean by congruent? It means they look the same and they have the same measure. Next, consecutive angles are supplementary. If you say supplementary, the sum is 180. So example, this angle and this angle, once you will add them, the sum is 180. Next, diagonals bisect each other. If you say bisect, it means it cuts the other one into half, exactly the half. So, example, this is one diagonal. This is another diagonal. If you say diagonal bisects each other, therefore this one, this part of the diagonal is equal to the other side. And this part of the diagonal is equal to the other part, like this one and this. The next one is each diagonal divides a parallelogram into 2 congruent triangles. Let's make one diagonal. Therefore, this triangle is congruent to the other triangle. Now, here's the Venn diagram for our quadrilateral family. This is the whole quadrilateral family. You can divide it into a parallelogram, a kite, and a trapezoid. A trapezoid has 1 pair of parallel and 1 pair of non-parallel. In a parallelogram, both are parallel. A parallelogram can be a rectangle if it has 4 equal angles. Or a parallelogram can be a rhombus if it has 4 equal sides. And a square is both a rectangle and a rhombus. Let me show you another Venn diagram. Now here. You can also place one more here. Remember the trapezium. A quadrilateral can be a parallelogram, a trapezoid, or a kite. It's a trapezoid if it only has 1 pair of parallel sides and the other pair is non-parallel. Its special type is isosceles trapezoid. Remember an isosceles? It has 2 equal sides. So the legs are equal. In a parallelogram, here, it can be a rhombus if it has 4 equal sides, or it can also be a rectangle if it has 4 equal angles. A rhombus and a rectangle with 4 equal sides and 4 equal angles, it's called a square. In a kite, the 2 consecutive sides are congruent. So here, that is a sample for a kite. Now, this ends our discussion, but let's first have a drill. You tell me whether it's sometimes true, always true, and never true. It's an example to your workbook, to your quiz today. Now, example, use your chat boxes. And here's my first statement. A parallelogram is a quadrilateral. A parallelogram is a quadrilateral. Is it always true, sometimes true, or never true? A parallelogram is a quadrilateral. Very good. It's always true, right? A parallelogram is always a quadrilateral. Next, number 2. A quadrilateral is a kite. A quadrilateral is a kite. A quadrilateral is a kite. Oh, very good. It is sometimes true. My first statement is a parallelogram is a quadrilateral. Always true. My next statement is a quadrilateral is a kite. It's only sometimes true. Why? Because not all quadrilaterals are kite, yeah, right? It can be a parallelogram, a trapezoid, or the rest. Next one. A rhombus, I'm checking if it's not in my quiz. A rhombus is a rectangle. A rhombus is a rectangle. A rhombus is a rectangle. Always true, sometimes true, never true. A rhombus is a rectangle. The answer is never true. Why? Because a rhombus can never have 4 equal angles. And a rectangle can never have 4 equal sides. Or else it becomes a square, right? Next, a parallelogram is a trapezoid. A parallelogram is a trapezoid. Very good. It's never true. Let me give you a hint. You see, I'm drawing arrows. This is called the parent in a family, right? The parent and the rest are children. If you go sidewards, it means they are siblings. So here, the first is a parallelogram is a quadrilateral. From child to parent, that is always true. Like a rectangle is a quadrilateral, always true. A trapezoid is a quadrilateral, always true. So child to parent, that's always true. Next, parent to a child. Parent to a child. Quadrilateral is a kite. That is sometimes true. Next, sibling to sibling. Like parallelogram is a trapezoid. That is never true. Rhombus is a rectangle. That is never true. What if, ma'am, a rectangle is a trapezoid? This is the auntie or the uncle, right? This is the nephew or the niece. Never true. So, any questions before we end today's discussion?